Friends, architects, engineers, hvac consultant and hvac students, welcome once again into VK Jan Sir ke MEP classes. In this particular module, we'll be learning about air conditioning basics. Friends, currently humanity is using mechanical air conditioning systems. These systems are of two types. One, vapor compression, and second, vapor absorption system. In this module, I am going to discuss the first one, which is the most prominent in the entire world. Vapor compression type mechanical air conditioning. All air conditioning systems use refrigeration circuit to chill indoor air, taking advantage of the remarkable physical phenomena. That is when any refrigerant gets converted to a gas in a process called phase conversion. It absorbs or rejects heat. All air conditioners exploit this feature of phase conversion. Many chemical compounds called as refrigerant have been found having boiling point much below the temperature that they are supposed to maintain in an enclosed space. But this is possible only 3 times atmospheric pressure only. Friends, air conditioning works by transferring heat from inside of a building to the outside using refrigerant to move as media to move heat through a cycle of evaporation, compression, condensation, and expansion. This cycle involves refrigerant absorbing heat at the evaporative coil inside, releasing it at the condenser coil outside, and then cooling back the desired space before repeating this process. This is known as refrigerant gas cycle. Although refrigerant cycle only is used in unitary type air conditioning only, its bigger system known as central chilled water system, we have three different heat exchanger systems. One, refrigerant circuit using heat exchange at two different places, that is evaporator and condenser. Second is water circuit. Water circuit in air conditioning units and evaporator and then condenser and cooling tower. Third is air circuits. Air circuit in EHU and enclosed room for which air conditioning system is being designed and cooling tower and open atmosphere. Friends, the first modern air conditioning system was developed in 1902 by a young electrical engineer named Willis Haviland Carrier. Willis Carrier invented the first modern mechanical type air conditioning system in Buffalo, New York to control temperature and humidity in a printing plant. This is considered the first true HVAC system because it's combined cooling, dehumidification, and air circulation circuit. Carrier Air Conditioning and Refrigeration Limited is currently engaged in manufacturing and exporting of ceiling suspended air conditioning unit, ducted air conditioning unit, and Fortune 500 company world over and very popular in India. To study the complete air conditioning systems, we have to learn heat transfer media. Air conditioning system involve many following heat transfer media circuits. These are refrigerant circuit, second one is water circuit, and third one is the air circuit. And heat is exchanged between refrigerant and air in case of window type, split type, VRF type, and direct expansion type via AHU, air handling unit. Second, the refrigerant to water heat transformer, heat transfer circuit is in chilled water type central systems. And the third one, water to air circuit is used in chilled beam and AHUs. So the most important portion of air conditioning is happening in heat exchanger. Heat exchanger of closed type is the most popular one. One example of this is double pipe exchanger. Now, this is one pipe is a cylindrical vessel and another type is tubular vessel. In this type, the hot and cold fluid streams don't come into direct contact with each other. They are separated by a tube wall or flat plate. Cooling coil, evaporator, chiller and condenser and cooling tower all are the heat exchangers. Friends, we shall learn through an example of simple cell and tube type of heat exchanger, which is shown in this picture here. It has got two circuits. Uh, Cell side, uh, when I say cell, it means the cylindrical structure. The cell side fluid goes inside this one and it adopts a longer route by virtue of semicircular baffles provided throughout the cell, that means cylindrical structure. So one type of fluid goes here, preferably which is refrigerant, and another side fluid flows in a system of tube headers. Number of tube joined through tube header, both sides. So this a number of tube they carry preferably water inside, and there is a heat exchange between the first fluid, which is refrigerant, and second fluid, which is water coming, this one coming and leaving like this. So the heat is exchanging, but both the media are not coming in direct contact. Friends, a cell and tube type heat exchanger explained in previous slide is one of the most widely used types of heat exchangers in HVAC system, especially in chiller and large scale central air conditioning plants. When I say large scale, it means more than 300 tons up to 2000 tons. A cell and tube heat exchanger consists of a large cylindrical cell containing a bundle of tubes inside. The tubes are connected to header on both the sides. One fluid flows through the tubes and another fluid flows outside the tubes but is inside the cell. Heat is exchanged between these two fluids without mixing with each other. In water-cooled chillers, the refrigerant flows in the cell and the chilled water flows through the tubes as I have shown previous. Heat is transferred from water to refrigerant, cooling the water for circulation in the air conditioning system. In condenser heat exchanger, refrigerant that is hot vapor condenses onto outside the tubes. Cooling water comes from cooling inside the tubes, absorbs the heat and carries it away to the cooling tower. Friends, through this schematic diagram, I have tried to I have tried to explain the sources of heat gain in enclosed premises. Now this is a enclosed premises which has got a wall having fenestration in between, and the inside of the enclosure is this, which contains animal, in this case human being, and the computer type system. Now in this, the maximum heat comes through solar radiation, which may be up to 700 watt per square meter of the glazed area, that means this fenestration area. And this radiation enters directly from sun to inside of the room. The second is heat gain through walls. This is wall, roof, floor here, etc. due to temperature differences. So this is uh, another type of heat coming inside. The third type of heat gain inside the enclosed atmosphere is through occupant. In case of sedentary occupants, that means a person sitting on computer table, sensible gain is of the order of 9 to 100 watt per person, and latent heat is of the order of 40 watts per person. This is for the male type of occupant. In case of female, it is slightly less. The fourth source of heat gain is sensible heat gain through office machines, up to 400 watt per desktop computer. And then we have sensible gain through lights, 15 to 25 watt per square meter of floor area, these two. So we have learned sources of heat gain in an enclosed atmosphere or premises. Friends, we are once again discussing heat gains. The first one is external heat gain. These come from outside the building through solar radiation through glass, transmission through walls, roof and floor. Heat flows into the room due to the temperature difference between indoor and outdoor of wall. Air infiltration. that is leakage. Hot outdoor air leaks inside through the cracks in doors and windows. Fourth is ventilation air. Fresh outdoor air required for occupants brings flexible plus latent heat as it happens in operation theatre. Second is internal heat gain. These are generated inside the room through the occupants, people and pets. Each person adds sensible heat and latent heat. Sensible heat through body temperature and latent heat through moisture from breathing or perspiration. Second is through lighting. Electrical light release heat usually considered 100% of wattage of their equipment. Third, equipment or appliances. Computer, printers, kitchen equipment, motors, etc. etc. generate sensible plus sometimes latent heat also. Say coffee brewer. Processes, if any, e.g. cooking in kitchens and machinery in lab, etc. Frank's typical heat gains are shown here for rough estimate in comfort air conditioning. People 90 to 100% sensible and 40 to 100 latent heat per person sitting and office work. Lighting 10 to 20 watt per square meter of floor area. Equipment 5 to 25 watt per square meter depending upon type of use. Fourth, walls and roof depends on insulation and sun exposure, often 10 to 30 watt per square meter. Then glass, windows and fenestration. They generate 200 to 400 watt per square meter when it is fully sunlit and 700 watt per square meter of glazed area in NCR on 20th May at about 4:30 p.m. The final rate of heat gain is the sum total of these. For example, a typical office room of 30 square meter with 4 people plus lights plus equipment may have around 5 to 6 kilowatt heat generated. In optimally in NCR region it is 1 ton equal to 3.517 of kilowatt. Friends, the mechanical air conditioning system is the process of altering the properties of air, primarily temperature and humidity, to more comfortable conditions, typically with the aim of distributing the conditioned air to an occupied space such as a building or a vehicle to improve thermal comfort and indoor air quality. In common use, an air conditioner is a device that removes heat from the air inside a building or vehicle, thus lowering the air temperature. The cooling is typically achieved through a refrigeration cycle, but sometimes evaporation and free cooling are also used. Air conditioning system can be made based on desiccants. Friends, the air conditioning process, in the most general sense, the air conditioning can refer to any form of technology that modifies the condition of air, namely heating, cooling, humidification in case of low RH air, dehumidification in case of high RH air, then cleaning of the air which needs filtration. Fourth, ventilation, that means air circulation. And seventh is air movement, direction of velocity. Uh, HVAC, however, in practice and in reverse cycle applications such as complete system is referred to as heating, ventilation and air conditioning system, HVAC. This term is quite often represented for cooling and heating systems. Friends, different type of processes, refrigeration temperature to be maintained may be quite different. Say for a process of comfort and productivity purposes, providing cool environment that enhances human comfort and increase productivity in workspace. Here, temperature to be maintained is 20 to 25 degrees Celsius through refrigeration temperature. Second is domestic refrigeration. Here the purpose is home or soft freezers. The temperature to be maintained is -5 generally, and refrigeration temperature may be -15. In the first case, the refrigeration temperature is normally of the order of -35 degrees Celsius. In case of food preservation, uh, the purpose is slowing down the growth of microorganisms and enzymes that cause food to spoil. Uh, for example, walk-in cooler, which is used for storing vegetables in hospitals and many other. Here the temperature to be maintained is of the order of -15 to 25 degree through refrigeration temperature of -35. Imagine. Then for purpose of freeze drying process, the purpose is in malls and other shopping centers preventing overheating in electronics machinery which can lead to malfunction of in malls and other shopping centers. The temperature to be maintained is -25 to 30 and refrigeration temperature of -35 to -45. In case of electronics and machineries cooling, uh, purpose is preventing overheating in electronic and machinery which can lead to malfunction of malfunctions or decreased efficiency. Here the temperature is to be maintained 20 to 25 degree Celsius through refrigeration temperature of 0 to 10 degree. Friends, there are 5 basic components. Maybe unitary air conditioner, that is window or split type, or even bigger systems. The basic components are the compressor, the condenser, the expansion device, the evaporator, and the refrigerant tube, which joins all these. The first four major components is split into two sections, indoor and outdoor. In case of unitary air conditioning systems, split type. In indoor units, we have the expansion unit and evaporative coil, cooling coil, known as evaporator. In outdoor unit, we have the compressor, which makes noise, and condenser, which requires direct air cooling. So they are kept outside. They are kept outside for the reason compressor makes noise and condenser emits lot of heat. These four major components are divided into two different pressure ranges, high pressure and low pressure. The high pressure side is the condenser unit outdoor and the low pressure side is evaporator. The pressure change is made by the compressor low to high and expansion unit high to low. So thanks for patiently watching my representation of this module and thanks once again.